Okay, so looking at this study guide, the very first thing we have on here is the Pythagorean Theorem, which we all know is a squared plus b squared equals c squared. Okay, so using it on, let's look at number 1. All you have to do is literally just use the formula and fill it in. So you have 15 squared plus 12 squared equals x squared. Okay, so 15 squared plus 12 squared is 369. And to solve for x, you would just take the square root of both sides here. So you have that x equals 19.21, and we're rounding to the nearest hundredth. So there is the answer. Okay, so let's look at the Pythagorean theorem converse in classifying triangles. Okay, so if you have that c squared equals a squared plus b squared, it's a right triangle. Okay, if you have that c squared is less than a squared plus b squared, then it is an acute triangle. If you have that c squared is greater than a squared plus b squared, then it is an obtuse triangle. Okay, so one thing I want to make sure that y'all do remember is that in order to be a triangle, the sum of the two smaller sides must be greater than the third largest side. So the sum of the two smaller sides must be greater than the third largest side. Okay, so let's look at some more examples of this. Okay, so looking at number 7. All right, in order to classify these triangles as acute, right, obtuse, or not a triangle, you have to check to make sure it is a triangle. So what you're going to do is you're going to add the two smaller sides together, 21 plus 20, and that has to be bigger than the third bigger side, which is 29. All right, so 21 plus 20 is 41, so it is bigger than 29, so it is a triangle. So now you have to see what kind of triangle we're looking at here. All right, so I'm going to put 29 squared right here. We don't know what if it's equal, less than, or greater than 20 squared plus 21 squared. Okay, so 29 squared is 841, and 20 squared plus 21 squared is also 841. So these two sides are equal, meaning it is a right triangle. Okay, looking at special right triangles, 45, 45, 90, and the 30, 60, 90. Okay, so you have to label these two sides. A 45, 45, 90, remember y'all, is an isosceles right triangle. So both of these legs are the same. That's a leg, and here's your hypotenuse. Remember, the hypotenuse is the side across from the right angle. I could also label these with, let's see, I could put an X here. Well, in theory that works. Let me get a different pen. Okay, so all right, here's X. This is also X because they're the same. And remember, the hypotenuse is the square root of 2 times the leg. Okay, so the equation for this, the hypotenuse is equal to the square root of 2 times the leg. Okay, so looking at the special right triangle, we have a 30, 60, 90. So the shorter side is the side across from the 30-degree angle. So this is the short leg. And then the long leg is the side that's across from the 60-degree angle. So this is the long leg. And obviously the side across from the right angle is the hypotenuse. Okay, so again, I could label these. I could label the short leg as, let's say, X. I'll just put it out here. and the long leg is equal to the square root of 3 times the short leg. So this would just be x root 3. And then the hypotenuse is equal to 2 times the short leg. So that would just be 2x. So we do have a couple of equations for this one, if y'all remember. So let's talk about those. Okay, so we have that the hypotenuse is equal to 2 times the short leg. And we have that the long leg is equal to the square root of 3 times the short leg. Okay, so looking at that, we have a few just equations. I want to make sure y'all remember. There we go. Okay, so let's look at some more examples. Let's look at number 13. Okay, so number 13, we have a 45, 45, 90, meaning it is an isosceles triangle, so we know that x and y are going to be the same. Okay, and for 45, 45, 90, we know the hypotenuse is equal to the square root of 2 times the leg. Okay, here the hypotenuse is 12. So we have 12 equals the square root of 2 times one of the legs. I'm just going to pick x. So we have the square root of 2 times x. Okay, so to solve for x, we need to divide both sides by the square root of 2. Okay, so those cancel right there. Okay, so you have x equals 12 over the square root of 2, but you can't leave a radical in the denominator, so we're going to have to rationalize it. So you multiply the top and bottom by the square root of 2. So you have 12 on the square root of 2 over 2 equals x. But 12 over 2 reduces. 12 divided by 2 is 6. So you have that x is equal to 6 root 2. And because y is the same thing, y is also equal to 6 root 2. Okay, let's look at number 16. Okay, number 16 is a 30, 60, 90 degree triangle. Okay, so we have the long leg because it's across from the 60-degree angle. Here's the 60-degree angle right here. Okay, so we need to set up our equation. We do have the long leg. We know what it is. So we're going to use that, and we can find the short leg, which here is x. Okay, so we have the long leg. I'm just going to write the equation first. So you have the long leg is equal to the square root of 3 times the short leg. Okay, so the long leg here is 69. So 69 equals the square root of 3 times x. Same situations we had a while ago. You have to divide both sides by the square root of 3 to solve for x. And so we have x equals 69 over the square root of 3, but you cannot leave a radical in the denominator. So you need to rationalize it. We're going to multiply the square root of 3 to the top and the bottom. So you end up with 69 root 3 over 3, but 69 is divisible by 3. So 69 divisible by 3 is 23. So we have 23 root 3. Okay, now to find the hypotenuse, it's just 2 times the short leg. So you have 2, so y is equal to 2 times 23 root 3. So 2 times 23 is 46. You have 46 root 3. Okay, so let's look at the similar right triangles in geometric mean section. Okay, so we know that the geometric mean of two numbers, a and b, is a positive number such that x is equal to the square root of a times b. So all that means, for example, in number 17 here, is that x is equal to 18 times 27. All right, and we know that 18 times 27 is 486. we need to, according to the directions, we need to simplify the radical. Okay, so I also know, come up here, that 486 is 81 times 6. I know the square root of 81 is 9, so we have 9 root 6. Okay, let's look at number 20. Okay, so here we're gonna use our knowledge of how to use these with the triangles. So we have the altitude of the triangle, which is x. So we have x squared is going to equal the two segments of the hypotenuse multiplied together. So 30 times 6. Okay, so to solve for x, we're going to have to take the square root of each side. So when we do, we get x equals the square root of 30 times 6, which is 180. All right, I know that 180 can be broken out to 36 times 5, and I can take the square root of 36. It is 6, and bring 6 out and leave 5 under. So your answer is 6 square root 5. Okay, let's look at another one. All right, let's look at number 22. All right, so number 22, again, you have a right triangle, and you have the altitude. You have the altitude drawn for the triangle, but you don't know the measurement of it. But it divides the hypotenuse into two segments. So we're going to look at the leg of the right triangle here, which we're given, which is x. And so x is going to be equal to, x squared is going to be equal to this segment of the hypotenuse that is adjacent to it, or is touching it, which here we don't have the measurement of it, but we know the whole measurement of the hypotenuse is 24. We know this section of it is 6, so 24 minus 6 is what? 18. Okay, so that right there is 18. All right, times the length of the whole hypotenuse, which is 24. Okay, so to solve for x, you're going to have to take the square root of both sides. When you do, you get x equals the square root of 18 times 24, which is 432. And we have to simplify the radical here. So I do know that 144, which is a perfect square, times 3 is 432. All right, so the square root of 144 is 12, so you'll have to 12 square root of 3. Which is your answer. Okay. So let's look at right triangle trigonometry, and we'll talk about the trig ratios. Okay, so remember you have a couple. You have that the sine of angle x is equal to the ratio of the opposite side over the hypotenuse. And you also have a cosine of angle x is equal to the adjacent side over the hypotenuse. And you also have that the tangent of angle x is equal to the opposite side over the adjacent side. Okay, so those are your three trig ratios. So I'm going to skip down to number 27, and where we have to solve for x and round our answer to the nearest tenth. Okay, so looking at this, I have angle 62 degrees right here. From this angle, what is the relationship to 16? It's not the hypotenuse, because the hypotenuse is across from the right angle. All right, so it is the opposite side of angle 62 degrees, and x here is the adjacent side. So what you do is opposite and adjacent, it is tangent. So we're going to do the tangent of 62 degrees equals the opposite side, which is 16, over the adjacent side, which is x. Okay, so I need to multiply both sides by x. Get rid of it here. I do, those x's cancel. And you have x tangent of 62 degrees equals 16. Okay, so again, to solve for x, I'm going to have to divide. So I'm going to divide both sides by the tangent of 62 degrees. So you end up with x equals, and you put this in your calculator, and we have to round to the nearest tenth, so we get 8.5. Okay. Let's go look at number 31. Okay. So number 31, you have to find the angle. You don't know what it is, but let's look at what the relationship of this is. All right, so you have your angle right here. 28 is the hypotenuse of the triangle, so you have the hypotenuse, and 19 is the side that is adjacent to this angle. So you have adjacent and hypotenuse, which means you're using the cosine. So you have the cosine of x equals the adjacent side, which is 19, over 28. Okay, you're going to have to find the angle, so you have to use the inverse of cosine. So x is going to be equal to the inverse of cosine of 19 over 28. Okay, if you plug that into your calculator, you're rounding to the nearest tenth, you get 47.3 degrees. Don't forget the degree mark, because I need to know that you know it is an angle measure. Okay, so let's look at angle of elevation and angle of depression. We're going to look at number 35. Okay, so Railroad Park decided to host an outdoor movie night on Saturday evenings during the summer on a large screen. Faith is sitting 34 feet from the base of the screen. Okay, so let's look at this. Here's the screen. Faith is sitting 34 feet away from it. She's way out here. Here's Faith. She's 34 feet from it. Okay, so she's watching the movie with her friends. And so the angle of elevation from Faith to the top of the screen is 26 degrees. Here's Faith. Here's her view to the top of the screen. And that is 26 degrees. Okay, so the question is, how tall is the movie screen? Okay, so you have an angle, and you have the side that is adjacent to it, and you have the opposite side. So you have opposite and adjacent, so you're going to use tangent to figure this out. So you have the tangent of 26 degrees equals the opposite side x over the adjacent side 34. Okay, so to solve this, you multiply both sides by 34. Okay, so 34's cancel over here. And you're left with this. So 34 times the tangent of 26 degrees. If you put that in your calculator, round to the nearest tenth, you're going to get 16.6. Okay, so the movie screen is 16.6 feet. Don't forget your feet tall. Okay, let's look at another one. Let's look at the parasailing one. Let's look at number 37. Okay, so parasailing on a beach trip to Florida, Riley spots a shark in the water below. Riley is 342 feet above the water. So here's Riley. Riley's way up here. Okay, here's the water. Okay, so she's 342 feet in the air. Okay, so the angle of, she's looking down at the shark. So here's the shark over here. All right, so the angle of depression, she's looking down, is 40 degrees. So this right here is 40 degrees. Okay, what is the horizontal distance between Riley and the shark? But before we get to that, okay, so you have two lines here. You have this as a line, and the base of this triangle is a line. So you have two parallel lines and a transversal. So we know that alternate interior angles will be congruent. So if this is 40 degrees, this angle in the triangle right here is also going to be 40 degrees. Okay, so we want to know what the horizontal distance between her and the shark. So just basically from here to here, from here to here. Okay, so setting this up, you have the angle 40 degrees, and the side opposite of it, the 342 feet, and the side next to it, which is x. You have the opposite and adjacent, which is going to be tangent again. Okay, so you have the tangent of 40 degrees equals the opposite side, 342, over the adjacent side, x. Okay, so to solve this, multiply both sides by x, Your x's cancel. So now you have x times the tangent of 40 degrees equals 342. Okay, so to solve this at this point, you would divide both sides by the tangent of 40 degrees. These tangents cancel out over here. Okay, so if you put 342 divided by the tangent of 40 degrees in your calculator, you are going to get 407.6 feet. And that's how far away Raleigh is from the shark. Okay, so let's look at law of sines and law of cosines. Okay, so for number 40, look at number 40. All right, you want to find x here. You need the angle opposite of it, but you already have these two angles, so you would just do 180 minus 33 minus 39, which is going to give you 108 degrees. That's what this angle is right here. Okay, so we use the law of sines. We have the sine of 108 degrees over x equals the sine of 39 degrees over 12. Okay, so you'll cross multiply. You get 12 times the sine of 108 degrees, and that equals x times the sine of 39 degrees. Okay, so to solve this for x, you're going to divide both sides by the sine of 39 degrees. Cancels over here. Okay, so when you put this in your calculator, 12 times the sine of 108 degrees divided by the sine of 39 degrees, you're going to get 18.1. All right, so this is 18.1. Okay, let's look at number 45. Okay, so number 45, we're going to be using the law of cosines, and you're going to solve and round your answer to the nearest hundred. Okay, so you have to find the largest angle first, which is what I have labeled here. Okay, so looking at this, you're going to use your side, which is across from the angle that you want. So this is, sorry, jumped around over here. Okay, so we want to do 19 squared equals the sum of those other two sides squared, so 10 squared plus 13 squared minus 2 times those sides times the cosine of x degrees. Okay, so we have that 19 squared is 361. 10 squared plus 13 squared is 269. Minus 2 times 10 times 13 is 260 times the cosine of x degrees. Okay, so I'm going to subtract 269 from both sides. So I get 92 equals negative 260 times the cosine of x degrees. Okay, y'all, so you have to find this angle. So you're going to have to do the inverse of cosine. So what I'm going to do is I'm going to go ahead and divide both sides by negative 260 and do the inverse cosine of it to get the angle measure. So it should look something like this. You have the cosine, inverse cosine of 92, that's a 2, over negative 260 equals x. So putting that, I don't know why that just did that. So putting that in your calculator, the inverse cosine of 92 over negative 260 will give you, sorry about that, I guess I got an email. All right, that will give you 110.72 degrees, and the instruction said nearest hundredth. So 110.72 degrees is that angle. All right, last one. Let's look at number 46. Okay, so in number 46, you're going to use the law of sines and law of cosines to solve the triangle and round the answers to the nearest 10. Okay, so I'm given all three sides. So I'm going to have to use the law of cosines first to find an angle measure, and I've got to find the largest angle measure. So the largest angle is across from the longest side. The longest side here is 9, so I'm going to find angle R first. I'm actually just going to label angle R here as X, just to make it a little easier for me when I'm writing this out. Okay, so to do this, I want my side that's across from the angle I'm trying to find, so it's 9 squared. That's going to equal the sum of the other two sides squared, so 4 squared plus 6 squared minus 2 times these two sides, 4 and 6. My handwriting is not working. Times the cosine of this angle. Now we're going to have to find the angle measure, so eventually we're going to end up using the inverse of cosine, but let's go ahead and get this as simple as we can until we have to do that. All right, so 9 squared we know is 81, and then 16 plus 36 is going to give us 52 minus 24 times 2, which is 48, cosine of x degrees. I'm going to go ahead and subtract 52 from both sides, so I'll end up with 29 equals negative 48 cosine x. Okay, so here's where I know I'm going to have to find the angle. So I'm going to go ahead and divide both sides by negative 48 and use the inverse of cosine to find x. So I have the cosine, negative 1, it's the inverse of cosine, of 29 over negative 48 equals x. So if I put this in my calculator, this part right here, all right, I'm going to end up with 127.2 degrees. So that's angle R, 127.2 degrees. Okay, so now I need to find one of the other angles. It does not matter which angle I find next. I'm just going to find P, and I'm going to label that as Y. Okay, so to do that, let's see, I have this angle. I need to know this angle, but I have the side opposite of it. And then I do know what angle R is now. It's 127.2, and I have the side opposite of it. So I'm going to use the law of sines. So I'm going to say the sine of y degrees over 4. Why is it doing that? Let's try that again. The sine of y degrees over 4 equals the sine of 127.2 degrees over 9. And then I'm just going to cross multiply. All right, so I'm going to have 9 times the sine of y equals 4 times the sine of 127.2 degrees. All right, y'all, so because I'm finding an angle again, I know I'm going to do the inverse of sine, so I'm going to go ahead and do that. So I'm going to have So I'm going to have y equals, I also have to divide both sides by 9, the inverse of sine of 4 times sine of 127.2 degrees, that's a 2, sorry about that, over 9. And when I do, I get that y equals 20.7 degrees. So that was angle P. So this is 20.7 degrees. And to find the last angle, all I need to do is I already know 2 angles of my triangle. So I just need to do 180 minus 127.2 minus 20.7, and I'm going to get 32.1 degrees. Okay. All right, so that was a study guide. Please email me if you have any questions at all. We are going to do an online test on Monday. I'm thinking I might make it Tuesday. I'll email y'all and let y'all know. But I do miss y'all, and I hope y'all are doing okay.